Hi, my name's Martin Bloor, and today I'll be talking to you about TDD, which stands for Test Driven Development. My target audience for this video are those people who are just getting started with TDD. I'll be explaining to you exactly what is TDD, what are we testing, why would we choose to use it, the benefits it delivers, and the common pitfalls of starting out. So what is TDD? Does it mean I'm just making sure I'm writing tests for my code? No. TDD is a technique for designing code. One of the principles of TDD is that we write the test first, not the production code. By writing the test first, we're focusing on the outside behavior of a unit or its interface. If I deliver a project using TDD, the code is going to be more cleaner and less complicated. This is because, as I'm writing the tests, I'm ensuring that the production code remains testable. Testable code is clean and simple so that we can isolate it in a test easily. Take a project without test code being considered, and we may have a very long running methods, complex object behavior, or spaghetti code where responsibility of objects is all over the place. So, back to the technique of TDD, it goes a little something like this. Firstly, we write a test. The test fails to compile because we haven't yet written the production code. Secondly, we stub out the production code just enough to make the test compile. The test at this point is failing, which is good. Thirdly, we produce just enough code to make the test pass. Now that the test is passing, we refactor both the test and the production code. As we refactor the code, we keep leaning on running the test to ensure it's still passing and that our code is still behaving as we initially intended. Then we begin the cycle again. We create a test, we make it fail, we make it pass, and we refactor. So what exactly are we testing? We are testing a unit of code, a discrete piece of code that we may see as a single method in a class. We isolate this discrete piece of code and verify that it's behaving as expected. Is it returning the correct result for good inputs? Does the method throw exceptions when I pass it invalid parameters, and so on? One unit of code usually has many specific unit tests to exercise its behavior. Isolating code can be tricky. One method may call into other methods or may use other components outside of its context. Excuse me. Let's take, for example, a method in a business tier that retrieves data. This method will talk to a data layer, which may want to talk to a real database to fetch the data. Any exceptions that may occur may be logged in an exception handling manager, which may fire off an email or log into other trace listeners. That's a lot of collaborating components when all we're concerned with is the behavior of the business method. Taking the method apart and seeing its actual behavior, we simply want to know that it did attempt to fetch data from the data layer, and did it pass any thrown exceptions to the exception manager. So what happens outside of that context, we don't really care. Other tests relevant to those other components will exercise their behaviors, which we're not concerned with. A lot of TDD introductions don't consider these real problems that we're working with, which makes it extremely difficult for beginning developers in TDD. We need to address these problems with design solutions and known TDD patterns. I hope to cover the basics of handling such a scenario in a later tutorial where we'll get to talk about decoupling code from concrete implementation so that we can mock the behavior of collaborating components to really isolate that small discrete unit of code. Now let's talk a little bit about why we would use TDD. As we're producing tests for each unit of code, we're naturally achieving high code coverage. Code coverage is the metric we use to see exactly what lines of production code we have exercised when we run the tests. High code coverage shields us away from nasty surprises that we may have encountered